All right, class. So let's talk about number system, right? So wait a minute. Yes. So number system is a way to represent the numbers. So a number system carries the set of symbols and it follows some rules. And these set of symbols and rules, they are used to represent the quantities. Like in our day-to-day life, we use decimal number system. Suppose I want to write 554, right? So this is a number which is following decimal number system, where we are using the numbers. We are using the symbols like 554, right? So number system provides a framework using which we represent the numeric values, and it defines how symbols or digits are used and combined to form the numbers. So number system, it could be the decimal number system, binary number system, octal or hexadecimal. And each number system has its own symbols and its own rules. So number system tells you how to crop all the symbols and how to represent the quantities using it. So let's talk about the number systems one by one. So first is the decimal number system. This is a system that we use in our everyday life. So decimal number system mean here base is 10. It mean a number will use digits from 0 to 9. It like 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Using these digits, we will define the numbers in decimal number system. Now, second number system is the binary number system. Binary number system, this is the foundation of digital computer. We know that the computer system has electronic circuitry which understands the signal, right? So if there is high or low, right? So if this is high, then we say this is 1. If it is low, then we say this is 0, right? So computer system understands binary language, right? It takes only 2 digits, 0 or 1. So that this system is known as binary system, which is called as base 2. It means it will use only 2 digits, right? So it will be 0 or 1. So it uses digits, or you can say symbols, 0 and 1. Now, next system is octal system. So this system is used in some computer applications, and octal mean here base is 8. Now, in this system, we'll use the symbols to define the numeric digit numbers. But here, we will use only digits from 0 to 7. So, we'll have digits like 0, 1, 2, 3, up to 7. So, this kind of system is called as octal system. Next is hexadecimal system. Hexadecimal mean hexadecimal, 6 plus 10. So you can say this is base 16. So, when we were having base 10, so we were using numbers from 0. So they were like 0 to 9. For base 2, numbers like 0 to 1. For base 8, numbers are like 0 to 7. So in base 16, we'll have numbers like from 0 to 15, right? But how do we use it? Like in hexadecimal system, we'll have numbers like 0 to 9 as it is, right? And then we will have numbers like 10, 11, 12, 13, 14, and 15, right? So in hexadecimal number, 10 is represented by capital A, 11 by capital B, 12 by capital C, 13 by D, and E, and F, right? So suppose there is any number like 210, right? So how to understand in hexadecimal notation, like it's 210 or 210, right? So to distinguish it, if this is 210, then fine. But if this is 2 followed by 10, so to make it simpler, we write like 2A, right? So in hexadecimal number, we use 16 numbers, 0 to 15, but it's like that from 0 to 9, we use, to represent 0 to 9, we'll use the same symbols 0 to 9. But to represent 10, we'll use capital A. 11 will use capital B, and so on. And for to represent 15, we'll use capital F. So we can say it uses digit, hexadecimal system uses digit from 0 to 9, and then letters from capital A to capital F, right? Now, hexadecimal system, they are used in computer programming and in web designing. Sometimes you might have seen that the color codes are defined using hexadecimal number, and then in the digital electronics, right? So there are different kinds of number system. Each number system uses its own set of symbols, and there are certain rules to define it. Now, we'll talk about these systems one by one. First is we'll see how to convert decimal number into binary number. So we know decimal number means there is a number which has base 10, and binary number is a number which has base 2. Mean in decimal number, we will use digits 0 to 9, but in binary number, we will represent the same quantity using two digits, 0 or 1, right? Now, conversion is very interesting and it's very similar, right? So, like if we'll convert decimal to binary and decimal to octal, so there is same process for the conversion. So, let's see how to convert decimal number into binary number. So, suppose we have a decimal number 14, right? So, the method is we will write 14 here, and then we'll divide this number by 2. So you will divide it by 2, and then you will write here integer value. So like 2 divides 14 7 times, right? Just write the integer value. And 2 can evenly divide 14. So there will be no remainder. So you will write here 0. So, you know, if we'll divide any number by 2, you will get only two kinds of remainders, 0 and 1, right? So, we will use these remainders to define the binary number. So, if you're defining this, dividing 2, if you're dividing 14 by 2, it will be divided 7 times. And then this is remainder 0. Now, again, we will divide this 7 by 2. So, this time, 3 into 2 is 6, right? So this is 7, this is 6. So here you will get remainder 1. Make sense? And then 2, again, you will divide this 3 by 2. So 3 divided by 2. So 2, so here 2 times 2 into 1 will be 2, right? And remainder will be 1 here. Now here, again, you will divide this 1, and then 2 into 0 will be 0. So remainder will be 1. Since here we have 0, so now we will stop here. Now, so we will start the number, we will divide the number by 2, and we will stop when we are getting 0 here, right? And every time we will record the remainders. So just look at here what we'll do. We are getting remainder like 0, 1, 1, 1. Now to get the binary number, we will write this in reverse order, bottom to top. So the number which is at bottom, it will become your MSB, most significant bit. So you will write this one first, and then this one, and then this one, and then 0, right? So this will be 1, 1, 1, 0, and this is in binary notation. And 14, this number is decimal, right? So 14 on base 10 is equal to 1110 on base 2, right? So this is a process to convert decimal number into binary number. Now let's see how to convert decimal number into octal number. Now suppose we have number 100. So this is a decimal number. So I can write like this. This is 100 and this is on base 10. Now I want to get a number, and it should be on base 8. So we know here on base 10 we can have digits like 0 to 9, but on octal number we will have digits only from 0 to 7. So idea is here, this is base 8. So we will write number 100. And now this time we will divide this number by 8. We will write the integer part here and we will note the remainders this side. So divide 100 by 8. So it will be 8 and here you will get 12, right? So, uh, so, and remainder like 12 into 8, it will be 96. So remainder will be 4. So we will record here remainder. Now again, we will divide 8. We will divide 12 by 8. So it will go one time, 8 into 1, 8, and remainder will be 4. Now next, this is 1. Again, you will divide 1 by 8. So it will be 8 into 0, 0. So remainder will be 1, right? So we are recording here the remainders. Idea is if you divide any number by 8 and you are recording the remainders, so you will get the remainder in range from the range 0 to 7 only, right? So eventually it will give you a number on octal base. So now here we have the remainders like 4, 4, 1. Again, we will write these numbers in reverse order, mean bottom to top. So you will write first 1, then 4, and then 4. So this is the number which is on base 10, and this is equal to this number which is on base 8. Interesting. So when we were dividing, when we need to obtain decimal to binary, you will divide decimal number by 2, and at every time you will record the remainder, right? And you will stop when you're getting here 0. Then when you need to obtain decimal to octal number system, you know remainder should be like number should be, it allows you symbols from 0 to 7. So you will divide the number by 8 and you will record the remainders, and then you will write the remainders in reverse order. So this will be the value of this number in octal number system. Makes sense? So here what we are using some symbols, and then we are applying the rule to make it a quantity in that particular number system, right? Now, again, this is very easy to understand now how to convert decimal number into hexadecimal number, right? So what we'll do here, I'm taking one number like 1457. Hexadecimal number mean we will divide it by 16. So we will first divide this number by 16. So here it is 91. And if we'll multiply 16 and 91, you will get 1456. So remainder will be 1, right? So this is the remainder. Now again, you will divide 91 by 16. So like 16 into 5, this is 80. So remainder is 11, right? And then again, you will divide this 5 by 16. So 16 into 0 is 0. So remainder is 5. Because it is 0, now we will stop here. Now next thing is to write these numbers in reverse order. So you will write first 5. So this is 5. Then you will write 11. So now you know we will not write 11. This is actually 11. So we will write B, right? So we know A is used for 10 and B is used for 11, right? So here this is 11. So you will write B. And then this is 1. So you will write here 1. So what's the thing? Like 1457. This number in decimal number system, and this is equal to 5B1 in hexadecimal number system. Make sense? So here we have talked about how to convert decimal number into binary, octal, or hexadecimal number, right? Now let's continue this topic, and now we will do the reverse translation. Like we'll convert binary number to hexadecimal, binary number to decimal, octal number to decimal, or hexadecimal number to decimal number system, right? So again, it has a similar process, but different processes there. So let's talk about this. So to make it clear, like suppose our objective is to convert binary, octal, or hexadecimal numbers into decimal numbers, right? So like idea is, suppose we want to get a number in decimal number system, right? And we have a number in another number system. So idea is we'll take the face value and the place value of the number, right? So we will take the place value and the face value, and we will multiply both. And this we will do for every digit in the number, and then we will add it. So this process will give you number in decimal number system, right? So this is n is equal to an rn plus an minus 1 r to the power n minus 1 plus a1 r to the power 1 plus a naught r to the power 0, right? So n is an integer with n plus 1 digits. R is the base, right? So AI will range from 0 to r minus 1, where r is the base. It will be more clear in the coming slide when we'll use it. So before doing any conversion, I'll just tell you how we can get a decimal number, how we can convert a decimal number into decimal number using this formula, right? So idea is we need to use the face value and the place value. So suppose we know in the decimal number system, the first is it ones, then tens, then hundreds, then thousands, then 10,000, right? And their place value, it's like 1, and tens is like 10, 100 it's like 100, 1,000 it's like 1000, and 10,000 is like 10000. So they are the place value, right? So now suppose we have a number 1962, right? So we know this is at ones, then tens, and then hundreds, and then thousand place. So what is the thing? We'll write here the face value into the place value. So this is the face value 2, place value is 2, and face value is 2, and the place value for this is 1, right? So you will write 2 into 1, and this will be 2, right? I hope you know what is place value or face value. I'll quickly tell you. Suppose this is 62. So face value is a number itself, like face value of 2 is 2, and the place value of 2 is 1. Now, face value of 6 is 6, but face value of 6, but the place value of 6 is 10, right? Because it is a tens place. So if we'll multiply 6 into 10 plus 2 into 1, you will get 62, right? So we will just taking the digits, and we are multiplying the digits with their place value. If we'll add up all forms, you'll get back the number. So here we are applying the same logic. 2, 6, 9, 1. They all are the face values. We will multiply every face value with their place value. So this is 2, and its place value is 1. So we will multiply it by 1. 2 into 1 will give you 2. Now this is 6. Multiply 6 with its place value, which is 10. This is at 10's position. So it will be 60. Now next is 9, right? So 9, and we will multiply 9 with its place value. This is at 100 place. So this is 100. And this will be 900 now. And next is 1. So 1 into, it is at third place, right? 1000 place. So you will multiply 1 by 1000. So you will get 1000. And then you will add all the numbers. So you will get the number, right? So what we are doing, we are just multiplying the place value and the face value. Now here, just look at this thing also. Like this is 0, 1, 2, 3, right? So first one's place we will write 0, and then 1, and then 2, and the 3. The same can be understood like 2 into 10 to the power 0, then 6 into 10 to the power 1, then 9 into 10 to the power 2, and then 1 into 10 to the power 3. So 10 to the power 0 will be 1, 10 to the power 1 will be 10, 10 to the power 2 will be 100, and 10 to the power 3 will be 1000, right? So this is a weighted value in the decimal number system. Now let's talk about how to convert binary number into decimal number. So logic is same. We will apply this equation and we will get the output. So before this, we know that we will multiply face value and place value, right? And then we will just add all the digits. So it's like number is suppose 1011000001. This is a number in binary. We need to convert it into decimal. So first we will write here, these are the face value that we have, right? And then we need to write its place value. Since the number is in binary, so we will write here r raised to the power 0, r raised to the power 1, right? And r is the base. And here base is equal to 2 because this is binary number. So you will write here 2 raised to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and so on, right? So here what you are writing base and then you are writing power. So base and power. So power will go like 0, 1, 2, 3, and so on. Then uh, in binary system, place value chart is like this. 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, and so on, right? So what we need to do, we'll take the face value, we will multiply face value with its place value, right? And then we will add up all these things, all these values. So this is 1 into 2 to the power 0. So it will be, its conversion will be like, I am writing from here. So it will be 1 into 2 to the power 8 plus 0 into 2 to the power 7 plus 1 into 2 to the power 6 plus 1 into 2 to the power 5 plus 0 into 2 to the power 4. I'm just multiplying like this, 0 into 2 to the power 4 plus 0 into 2 to the power 3 plus 0 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0, right? So if I'll solve it, it will be like 1 into 2 to the power 8. This will be 0. And then 1 into 2 to the power 6, right? Plus 1 into 2 to the power 5. Then these all terms will be 0. I can cut them. And then 1 into 2 to the power 0. So 1 into 2 to the power 8, it is 256. Plus 1 into 2 to the power 6, it is 64. Plus 1 into 2 to the power 5, it will be 32. Plus 1 into 2 to the power 0, it will be 1, right? So if you will add up it, this will be like 353, right? So this is a number in base 2 and this is equal to 353. So this is on base 10. Make sense? You'll just take the digit and then you will multiply it with its place value, right? And then you will add up and that will give you the decimal value, right? Now, next to the next conversion, this time we will convert octal number into decimal number, right? So again, for octal number, we need to write the base. So in octal number, base is equal to 8. We need to write octal place value. So place value is like 8 to the power 0, 8 to the power 1, 8 to the power 2, 8 to the power 3, 8 to the power 4, 8 to the power 5, and so on. And for our convenience, I have just written its calculated value. You just please ignore this line. There is no sense here. And then this will be 8 to the power 0 is 1. We know the power 0 of any number gives you 1. 8 to the power 1 is 8. 8 to the power 2 is 64. 8 to the power 3 is 512, and so on, right? Now, suppose we have this number 462 in octal. Then what we will do, we'll take the digit. This is the face value. We will multiply this number with its place value. So, this is at ones, this is at tens, and this is at hundreds, right? So we will multiply this with its place value. This is 8 raised to the power 0, 8 to the power 0 into 2 plus 6 into its place value 8 to the power 1 plus 4 into its place value 8 to the power 2. So then you will just solve it and you will get the value. This, if you will multiply and solve it, it will be 306. So what we are observing that 462 on base 8 is equal to 306 on base 10, right? So what we are doing, we are just taking the number and then we are multiplying the number, or you can say the symbol, with its place value, and you will get the number in decimal. Make sense? I hope this is clear to everyone. Feel free to ask me question if you have any doubt. I will be happy to answer your queries. Now, we will apply similar logic to convert hexadecimal number to decimal number, right? So again, we'll do the same or similar approach. Suppose hexadecimal number is 1, A and B. So 1 is okay. A mean 10 and B mean 11, right? Now we have, the symbols at every, we have the face value, right? Now we will multiply these thing with its place value. So like 11 into place value. So place value here, like this is hexadecimal number system. So base is here 16, right? So we will do 16 to the power 0, 16 to the power 1, 16 to the power 2, and so on. So this is at ones. So you will write 11 into 16 to the power 0. This will be 1. So 11 into 1 will be 11. Next is, this is at tens. 10 into 16 to the power 1. It will be 160. Next is, this is at hundreds. So you need to write this one, 16 to the power 2. So 1 into 16 to the power 2, it will be 256. Now we will add all these values and we are getting here 427. So 1A, B in hexadecimal number system is equal to 427 on decimal number system. Easy class? I hope. Now let's talk about, so till now we have discussed how to convert decimal number into binary, octal or decimal number, hexadecimal number. And then we talked about how to convert binary, octal or hexadecimal number into decimal number, right? Now next is, these are some interesting and quick translations that we can do, or the conversions that we can do. Like, see, suppose you need to convert octal number into binary number, right? So one way is that you can convert octal number into decimal number, and then you can convert decimal number into octal number. So you can do like this because you have studied these approaches. So you can do it in 2 steps, but there is direct method also and very interesting. What to do? Like number is suppose 462. This is in octal number system. Now to convert this into binary number system, you will take the digit one by one and then you will write it binary form in 3 digits. Like suppose number is 2, right? So binary form of 2 will be, consider this as decimal. Binary form of 2 will be 0, 1, 0, right? So just look at this table. Like suppose octal number is 0. So binary form will be 0, 0, 0. If octal number is 1, then binary will be 0, 0, 1. If octal is 2, then binary will be 0, 1, 0. Octal is 3, then binary will be 0, 1, 1, right? So like 0, 1, 1, how this is 3? This is 0, 1, 1. So if you want to write in decimal, so it will be 0 into 2 raised to the power 2 plus 1 into 2 raised to the power 1 plus 1 into 2 raised to the power 0. So this will be 0 plus 2 plus 1. So it will be 3, right? So you need to multiply every digit with its place value, like this 2 and this 1. So you will get this number. Similarly, this is 1, 0, 0. So they are 0. And the place value for this is 4. So you will get here 4. So here we are writing every number in binary form with using 3 digits. Like this is 7. So this should be 1, 1, 1 because place value for this is 4, then 2 plus 1, right? So 4 plus 2 plus 1 will give you 7. To make 6, you need to make these two digit 1 and this 0, like 4 plus 2 and this 0. This will give you 6. So how to convert octal number into binary number? You will take the digit one by one and then you will write its binary form, a binary number in 3 digits. So 0 will be 0, 1, 2 will be 0, 1, 0. 6 will be, it's like 1, 1, 0, right? So you will write 1, 1, 0. And 4, it's like 1, 0, 0. So this is 1, 0, 0. So this is the number in octal number system, and this is its binary conversion. So you can directly convert. Similarly, suppose you want to convert binary number to octal number. So you can do this conversion directly. This is your binary number. What you need to know, this is binary number. You need to make a pair, and in every pair, or you need to make a block, and in every block you will use 3 digits. So you will start doing this process from right to left. So you will make first pair, then you will make second pair, and so on, right? So you will first block with 3 digits. So this is the block with 3 digits, 0, 1, 1, right? So for 0, 1, 1, we can write 3. So here we will write 3. And then again, we have 0, 1, 1. Okay, this is same. So this will give you 3. So this is the number value in binary, and this is in octal, right? So we can do in octal. So this is just the elaboration, like 0, 1, 1. So you will multiply every digit with its place value. So this will be 0, but this will be 2, and this will be 1. This will be 3, right? I have written it from the table, but this is its expansion. So you can convert binary number to octal number directly. Same process is there when you want to convert hexadecimal number into binary. So hexadecimal number goes up to 15, right? So it requires 4 digits in binary. So suppose hexadecimal number is 0. So in binary, it will be 0, 0, 0, 0. So we will use 4 digits to represent a binary number. So, and suppose this is 8. So in binary, it will be written like 1, 0, 0, 0. And if A, it means 10. So it's like 1, 0, 1, 0, right? So because you know the place value like 8, 4, 2, 1. So to make 10, you need to take this one, and remaining places should be 0. So 8 plus 2 will give you 10. Similarly, this is E, right? This is 14. So to make 14, what you need to do, you will take 8 plus 4, 12 plus 2, 14. And you need to take this as 0. This will give you 14. So we will write every hexadecimal value in binary form using 4 digits. So now hexadecimal number is suppose 1B7. Now what you'll do, you'll take the number 1 by 1 and then you will write its binary number, binary form in 4 digits. So 7 can be written as 0, 1, 1, 1, right? So you will write here 0, 1, 1, 1. Now for B, you will write the value for B in 4 digits. So this is 1, 0, 1, 1. Next, this is 1. So 1 can be written as 0001. So this is 0001. So this is direct conversion for hexadecimal number to binary number. Now look at its vice versa. Like suppose binary number is given and you need to obtain its hexadecimal number. So again, what you'll do, you will make the block and here you will group the numbers. So you will write 4 digits in one block, right? And then you will do the reverse process. So you will make the blocks and you will make the grouping from left to right. So first you will make this block, then this block, and then this block. Then here you have 0101, which is 0101. This means 5. Then 0011, so which is 3. And then 1011, and this is B. So conversion of binary to hexadecimal will be B35. So this is for binary to hexadecimal number. And we can compare the number systems. Like here I've compared the values for like numbers from 0 to 20. Like this is 0, and suppose this is 12 in decimal value. So it will be 14 in octal, but it will be C in decimal, but it will be this in binary number system. So it's interesting to see the arrangements of, or you can see the numbers. And here we are having the symbols. It's not 14 of decimal. Here we have symbols like 1 and 4, and it has its rule, which is making the number in that number system, or you can say the quantity. So we analyzed here that the different number systems have their framework to define the quantities. Yes. So this is all for today. This is all for this lecture. In next lecture, we'll talk about conversion of infix, prefix, and postfix notations. So have a nice day.